Division property of square roots. If you have the square root of something over something, you can break it up into the square root of the numerator over the square root of the denominator. Your steps of simplifying. Please write these down. First of all, you reduce what is under the radical or outside. Anything that you can reduce, you reduce first. You make it as simple as you can before you go on to the next step. Okay. The next step is you simplify your numerator or denominator. What do I mean by that? I mean what you learned for today's lesson is you take out pairs of factors. That's what we were doing, that they were in a group of two. You do that both to the numerator and the denominator. The third step is you rationalize, and you will learn what all this means today. Rationalize the denominator. Your final answer can never, never have a radical in the denominator. It's not simplified. A radical 3 is an irrational number. Radical 5 is an irrational number. So you have to make it without the radical. Okay? And I'll show you how. And the last thing is you reduce your answer. Your final answer if needed. Sometimes you don't need to. Now we're going to start with really easy ones and we're going to build up to the harder ones. So at the beginning of these, if I ask you, Eve, can I reduce 16 over 25? Can I reduce that fraction? No, I can't. So I can't do the first one. But can I simplify if I break it up by the rule of a radical over a radical? Can I simplify the square root of 16? And what would that be? 4. And what's the square root of 25? 5. You're done. There's no radical in the bottom. You're done. Like I said, we're going to start off easy. Very good. Peter, on this one, can I reduce this? No. Can I simplify the square root of 11? How could I split it? You can't. There aren't any factors of it. It's prime, isn't it? Okay. How about if I had the square root of 49? Because that's 7 times 7, so you would have radical 11 over 7. You are done. You can have a radical in the numerator, not the denominator. Yep, you will. Okay, we're going to get there. We're starting in baby steps. Okay, Miriam, what would we do? Can we reduce 25 over b to the 4th? No. But if I break it up into two radicals, can I simplify it? I'm on step 2. I'm simplifying the numerator. Can I simplify the numerator? Yes. What would that be? And what would the denominator be? b squared. Amir, on here, if I split it up into numerator over denominator, what's the square root of 144? And what's the square root of 9? Am I done? I'm going to reduce my final answer, which is 4. If you left it there, you didn't get it all the way down. Okay? Arturo, how would I simplify the square root of 25p cubed? And the square root of q squared. I can't reduce, but how would I simplify that? 5p what? P2, did you say? No. I agree that the square root of 25 is 5 because this is 5 times 5, right? But when I take the square root of p cubed, what would that be? You'll have 1 left over, so you'd have radical p. Because it's 3 divided by 2 is 1 with 1 left over. Getting a little harder, and what's the square root of q squared? Q. Awesome. Can I reduce anything? No, there's nothing like terms. Yes.
Shouldn't it be like 5p squared?
No, because it's 3 p's here.
Yeah, but don't you take 2 out?
I take only one group of 2 out. Right? Okay. Okay, Victor, on this one, 75 and 16p squared. Can I reduce those first?
No.
Can I simplify square root of 75?
No.
Yeah.
6 into 5 and 15.
5 and what?
15.
5 and 15, and how can I factor 15?
3 and 5.
So what could I take out? A 5, and I'd have 5 radical 3, right? How about on the bottom?
4p.
4p. So basically all of them, all we did was the second step here. We just simplified the numerator and the denominator, but in number 4 we also did step 4, we reduced the final answer, right? To get to my final answer. Okay, now let's look at this part. Sawhill, can I reduce this first?
Yes.
And what would the 88 over 11 be?
8.
Square root of 8. Okay, now can I simplify that?
Yeah, 2 radical 2.
Very good, because it's 2 times 2 times 2, so you would get 2 radical 2. Very good. Corinne, on this one, can I reduce this?
Yeah.
And what would that be?
6. And 8 and 3.
Good. And now can I simplify that?
You can do 2 and 3, and then a. Well, it would a times a, but it'll end up as 6a under the radical, and then with 1a.
Very good. Because 3 divided by 2 is 1 with 1 left over. Dylan? Oh, no. Urara, what would you do for number 9? And what would you get? 18. And how would I factor 18? Leo can see this.
3 times 3 times 2.
No, it's Urara. I guess it's Jake's. We'll come back to you, Urara. So what would you take out, Jake? How would I simplify?
Take out 3.
And be 3 what?
3 square root 2 as the
Huh? It'd just be 3 radical 2.
radical.
Okay, Urara, let's do this one. Yes, question?
I thought you know something interesting. So you know simplified radical with 8 over 8 over 1. Like if you multiply the outside one by the inside one, and multiply it again by the outside one, you get
If you multiply the what?
like you know how you got 6, 8 cubed, and you simplify it to 8, like the radical 6a.
Uh-huh.
If you multiply a by 6a, and multiply it by a again, you get 6a cubed. You do the same for number 1, you get 18.
You show me, I don't.
I'll show you.
Yeah. I'm not following you, but I'd like to see what you're talking about. Okay, Urara, can I reduce this? Divide by 2? 3. Okay, and what would I get here? 16 over radical 25, and can I simplify that? To what? Beautiful. Okay, JJ, can I reduce this?
Yes.
And what would you get?
909x squared.
Good, because remember our rules of exponents, we subtract them. Excellent. And then what would that be?
3x.
3x. Okay, so this one basically we reduced and we simplified. Okay, oh, one more. One more. Justin, what would you do here?
You'd simplify,
Okay, you'd reduce.
and you could,
And what would you get?
4 over 1, or x cubed over 1x,
Okay, and how could I reduce the x cubed over
or
x?
x squared.
Right? And then what would you get?
2x.
Good. Okay, now, remember your answer cannot have a radical in the denominator, so you have to remove it. If my problem was this, 2 over radical 5, I am going to multiply. I can't reduce it. I can't simplify radical 5 anymore. So I multiply it by radical 5 over radical 5. I'm really just multiplying it by 1. So I'm not changing the value of that fraction. And you get 2 radical 5 over 5. Because a radical 5 times a radical 5 is just 5. Can I reduce these 5s? No, because this one is irrational and this one is rational. This one is under a radical sign, this is not. You cannot just cancel and say, oh, that's 1. No, no, no. So, William, what would you multiply both of these by? Radical 7. And what would I get? Very good. Jake, what would you get on the next one? What do you think you do first? Be careful.
I'm kind of confused.
Okay, what is my first step here? Hatif, what would I do first? Can I reduce it?
Yes.
What can I reduce? 6 over 3 would be 2. Now I can't have a radical in the bottom, so what would I have to multiply by? Radical 3 over radical 3. So you're going to get, what's your final answer? 2 radical 3 all over 3. Can I reduce those? Nope. This is your answer. Okay, now we're going to start into the harder things. Dylan, can I reduce this? No. 7 over 8, they don't have a common factor. So first step, no. Step 2, can I simplify radical 7? Please pay attention. Some of you might be doing this wrong. Can I simplify 8? Are there pairs of factors? 2 and 2 and 2 and an n, so what can I take out? So what would I have here?
2, and then inside, then inside would be 2.
It would be 2n. Awesome. Okay. Now, stay with me. I have a radical. I can't have a radical in the denominator. How am I going to get rid of the radical 2n?
You have to multiply by radical 2,
2n.
of radical.
So now what do I get in the numerator? What's radical 7 times radical 2n? 14n. You just multiply the 2 together. Okay, Dylan, if I multiply radical 2n times radical 2n, what do you get? But you just get
Just
2n. And I multiply it with this 2, what would I get? 4n. Can I reduce this? No, this is under a radical, this is not.
Oh, okay.
You are done. Those of you that just multiplied by radical 8n, you got the wrong answer. This is where you have to watch your steps. You want to rationalize at this step right here by the smallest amount. So that's why we reduce the fraction first and we simplify the numerator and we simplify the denominator. And after those 2 steps, we rationalize. You won't get the right answer. Okay, so Nina, on this one, can I reduce it?
Yeah.
How?
It's radical 18 to
So you're simplifying it, right? Okay, how would I simplify that? What times what is 18?
3 in the radical 2.
Okay, because you have 3 times 3 times 2 times t, right? So you're going to get, she said, 3 radical 2t. You do that first before you rationalize. Rationalize is at the end of the whole process. So now I have to get rid of the radical sign, so what am I going to multiply by?
Radical 2t.
Radical 2t over radical 2t. I'm not changing the value, I'm really just multiplying by 1 here. And so, what do you get in the numerator?
10t.
10t, and on the bottom? 3. 3 and what's radical 2t times radical 2t? It's just 2t. You'd have radical 2 times t times t. You could take out 2 and t. So you have, what would I have in the denominator, class? 6t. There's your answer. Oh, I shouldn't have 10t squared. Thank you. Okay.
Oh, I thought it was G squared.
No, it's just t.
No, you got me confused. You did wrong.
I'm sorry. Cameron, what would you do on number 18? Can I reduce it? Okay. Can I simplify radical 7m? Can I simplify radical 10? So now I have to rationalize it. What would you rationalize it by? Square root of 10. And you would get, and there's your answer. Okay, everybody try number 19 on their own. Shawnee, will you make a note on your note taker for us to make a copy before 5th, and we'll give it to Ariel? Is it completed? Yeah, because that's the one that you use. Okay, good.
You want me to make it the end?
You could, that's kind of late. It's kind of late.
Okay, then I'll do it tomorrow?
Yeah, just like yeah. I meant to do it today, 4th, or 3rd, and I forgot.
Write myself a note.
And you maybe have to bring it this way, or the other way.
I think it shows my rule right here. Corinne, what did you do? Can you reduce this?
Sorry, I wasn't paying attention.
Number 19.
I don't think we can.
11 over 12, you can't reduce, can you? So what's your next step?
So your next step is to factor 11. Well, it's a prime number, so let's say 11.
Okay, good.
12 is 3 and 4,
And 4 is?
2 and 2.
So how would I simplify that?
So it would be the 2 and then an x would be outside, and then 3 and x would be outside.
Okay, can I leave it like that?
No, you have to rationalize the thing.
Good. So what am I going to multiply it by?
You're going to multiply it by is it just, I'm not sure, sorry.
Who knows? What do I just, Peter? Just the radical 3x. The 2x is already outside the radical. I'm not going to have to worry about that, am I? Okay, so Peter, what would I get in the numerator now? And in the bottom? Awesome. Because this times this is 3x. 3x times 2x is 6x squared. Can I reduce anything? No. Okay, one last one to try that I'm going to make up right now, number 20. Radicals, it's similar to the last one, but for those of you that didn't get that. So let's try that one. And then I want to talk about what's in the lower right-hand corner that we have. I think they have it. I was confident putting down your pencil. Okay, what did you do first, Sohail?
Radical 6 over 3x, radical 2x.
You might get to the right answer, but what's the first step that I'd like you to do? Reduce. You would have had 1 over 3x cubed. Okay, so then Amir, the square root of 1 over the square root of 3x cubed. So what's the square root of 1? And how would I simplify this?
X and radicals.
3 and x. Okay, Miriam, what do I have to do to rationalize that? Uh-huh. Okay, Corrine, are you getting this? Good. And what would then what do you get now?
3x times
Radical 3x, right?
1. No,
All over,
over, um, 3x squared.
3x squared. This times this is 3x. Multiply it with the x, and you get the 3x squared. This is your final answer. JJ, have it? Did you get it? Good. Okay, so if you follow the steps, if you don't follow the steps in the order, you may not get there. Did you get there? No. You're going to reduce it? Yeah. So please reduce first. So this is the steps in simplifying. And to be simplified, these are the rules too. You can't have any radical in the denominator. The hole punch went through that. No fractions under a radical. You can't have like that because you have a radical in the denominator. And no perfect squares under a radical. What that means is you can't have pairs of factors under the radical. Because if you have pairs of factors, that means you can take something out. It can be simplified. So please go in this order. Reduce, simplify numerator, simplify denominator. If there's a radical in the denominator, you rationalize it and then reduce your final answer. Any questions on that? Yeah.
On number 18, why did you multiply the number to 10?
Because it's a radical. And this is 2 times 5. So you can't take anything out. You have a radical in the denominator. No answer. Look at all my answers here. None of my answers. Turn it off.